All right. So in this one, we're given a couple of variables and told a little bit about a sort of larger project. And then we're going to have a couple of questions about this data set, and then some questions we might try to answer. Okay, so this is a bunch of questions. Let's see how we can answer them. So I would say that the best strategy here is to look at the questions and then see what we can do with the data set for the questions. So the first one is that an economist wants to test whether the relationship between income and spending is different during recessions. So how would we model this appropriately? So, I mean, if I was looking at this, I would think income, spending, and then also recessions. And so I would look at what the variables are doing for us. So we have, spending. I have income. So this is monthly household income in thousands of dollars. And then I have this recession dummy variable. So this is, it's 1 if it's happening during a recession, and then 0 otherwise. So if I was thinking about this question, I would, I'd set up, let's say spending is equal to beta 0 plus beta 1 times income. And then I'd be thinking about how to model differences during recessions. So one thing I could do is include just another variable here. So we could call this recession. And then with a beta 3, which, so we would want some interaction between income and recession. So this gives us a different intercept term for periods with recessions. So maybe spending is just down, but we would also want to test whether there's a relationship between income and spending that's different during recessions. So this would be a third beta. So this is this would be similar to our education premium by gender. So this is like with income. I can't spell even on a demo. So income times recession, and then we just have our error term. So this is what I would write, and then we can just check to see if any of these are available. So, or if this one is available with any of these. So that's not. What this does is it does have a beta 2 and a recession, but what we're looking for is a slope on the different income during recessions. So is there a different relationship during recessions? So that's really going to be an interaction term. And we see that in beta in B. So spending is equal to beta 0 plus beta 1 income. So we got our slope for non-recession times. Then we have beta 2 times recession. So this is the different intercept for baseline spending during recession. So we just expect beta 2 to be negative here. And then beta 3 is the interaction. And this is actually exactly what we've written here. So I'm just going to select this. We can go through the others. So this third one is looking at age and children, but not looking at recession. So this is like an immediate no. This one we have just the intercept term. So again, it's very similar to A, just with logs instead, which logs might be most appropriate here. So maybe the most appropriate one would include a different y variable, but nonetheless. So B is our answer here. So for question 2, the economist wants to understand how the proportion of online purchases relates to overall spending while controlling for income. So we're going to look at spending and then try to figure out how it relates to online purchases once we've controlled for income. So she suspects that different age groups may have different online spending patterns. So which would be the best model to capture this relationship. So if I were just to write this out, I would have spending is equal, so we're trying to, baseline get a sense of the relationship between spending and online purchases. So we would have beta 0 plus beta 1 times online purchases. And this isn't a variable we've used before, so I just want to, check this. So we'll just use maybe on the line directly. So this is just a percentage, so it's a numerical variable. Okay, so that's beta 1. And then we also want, so how spending relates to online purchases, but we also want to control for income. So let's put in a beta 2 times income. So this just, allows us to compare two different households with the same income and then check whether whether their different online spending habits are related to spending. So if you're spending a larger percentage of your income on online, are you spending more? So if that were true, then beta 1 would be positive. Okay, so then the main part of this question, though, is about whether there are differences by age group. So do different age groups have different online spending patterns? So let's look at age. So we have age as the primary household decision maker. So this isn't a binary variable, but we can still interact it with income. So what this would do for us is tell us every time we increase age by 1, how much extra is income related to spending. Or I guess this question is about online spending. So same idea, but just for online spending. So with beta 3, this is, we want online spending times age. And then we'll put an epsilon here. So what this does is it tells us when we increase age by 1, how much extra are we spending, how much extra is our online spending related to spending. So as a percentage, how is that related to spending? So this interaction term, it's the same interpretation as a binary variable, as a dummy variable that we've used for interactions, but it's just not binary. Okay, so now let's just check and see if any of these sort of correspond. So here we have spending is equal to all of these things, and this looks pretty reasonable, except that we don't get this interaction term. So we want to be able to establish whether online spending is different by age group. And this doesn't do that for us, because all we're seeing is that we're able to check whether spending is higher if you're older. Okay, so B, we have spending is equal to beta 0, nice. Beta 1 times income, nice. Beta 2 times online, nice. Beta 3, online times age. So this is our interaction term, which captures that differences by age group, and then error term. So this is actually, I think this is exactly what I've written down. So this is a plausible candidate. And then here we have C, which is beta 0 plus beta 1 times income plus beta 2 times online. And then we've also thrown in an age control here. And this, this could be a good option. It just sort of depends what kind of thing we're trying to answer. Whether we should control for age or not is, I guess, sort of related to how we interpret this question. So I would say this is also a good candidate answer. And then this last one, we have spending is equal to beta 0 plus beta 1 times income plus beta 2 times log online, and then log age. So this doesn't give us any interactions, so this is not correct. But either one of these would work for me. This is the only difference between the two, and it would give us, slightly different interpretations for what we were doing here. But from this question, there's not enough information to know whether we should include this. Okay, so question 3. The economist observes that the relationship between income and spending appears to be nonlinear, with the marginal propensity to consume decreasing at higher income levels. So which transformation would best capture this? So here we have a nonlinearity, and so the sort of relationship between consumption and income seems to be going down as income goes up. So, I mean, one thing we could do here is include a square term. So this would give us, so like spending is equal to beta 0 plus beta 1 times income plus beta 2 times income squared. And so we could, capture any potential relationship between spending and income. So if it were nonlinear, we'd be able to capture some of that. So it's like as a percentage of our income, spending seems to be going down because income is going up. So we spend more, but just as a smaller percentage of our income. Okay, so we could go through some of these other ones. Log income may be appropriate. So this, could be a good answer here. I would say the other two are just not quite in the sort of ballpark of correct transformations. Although they would do something. Okay, so quarter 4, the data shows high autocorrelation in residuals when modeling time series spending patterns. Which approach would most effectively address this issue? So nice. So this is one of those, whenever we run these kinds of models, we have to check the assumptions of OLS. So what we're doing here is just trying to fix one of the common violations of OLS, especially when we're thinking about data like these things. This is, time series data. So modeling with robust standard errors, this is good for heteroscedastic residuals. So when we see, something like this, where the variability increases, so like our model estimate, so when the residuals seem to be spread out in different ways for different estimates. But this is not going to fix the problem of autocorrelation. So B, modeling changes in spending. So instead of looking at spending directly, we're looking at the change in spending rather than levels. And this is a sort of the standard tool that we've used. C, adding more demographic control variables. Well, this there's a possibility that this could actually fix the problem. It's just we don't know enough to be able to say whether it will. So D, including lagged spending as a predictor variable. So this actually can work. This is very similar actually to taking a difference, but we just haven't spent a lot of time talking about this. It's a little more complicated. This one is going to be just a clearly a good first step at trying to address the problem of autocorrelation. Okay, so question 5. The economist hypothesizes that the effect of having children on spending varies by both income level and whether purchases are made online. Write out the complete regression specification using beta coefficients to test this relationship. So when we're thinking about writing out our own regression equation, what we want to do is think about, first off, what should be the outcome variable. And I mean, with almost all of these, the outcome variable has been either spending or like change in spending. So if I'm seeing this question, I want change in spending to be the outcome variable. It's sort of better with autocorrelation, especially when we're dealing with time series data like this. So then the main part of the question is that the effect of having children on spending varies by both income and whether purchases are made online. So we have a lot of things going on here. So I'm going to include some of the obvious stuff, or not necessarily obvious, but the sort of first level kind of things. So this is beta 0 plus beta 1 times children. So we have a children variable, so we'll just use children plus beta 2 times income. And then online, so beta 3 times online. And then what we're asked here is the effect of having children on spending varying by both income and whether purchases are made online. So we would want an interaction term. This is actually a pretty complicated regression equation. So this is, we want an interaction effect with income and online. So this is, say, beta 4 times children times income. So this is like our interaction. So does the effect of income on spending depend on how many children you have? And then we also have our beta 5, which is this is similar to what we did up here, or up here. Here, where we have income times online. Okay, and then we have our error term. This is a pretty tough question. I include this to show some of the complexity of these kinds of questions, but as I'm talking this through, I'm a little bit afraid that this looks very daunting. Another kind of question we could ask is, I'll rewrite this question for like a question 7 at the end. But I just want to say this is pretty difficult in terms of regression equations. So don't let this scare you off too much. So question 6, the data shows clear monthly seasonal patterns in spending throughout the year. So A, write a regression model that would identify these seasonal patterns while controlling for income and age. So we want seasonal patterns in spending throughout the year. So this is like we have our month observation. So what we want is maybe spending as the outcome variable. And then I'm going to include one control variable for each month. So we can write this out in sort of Python terms, but I'm just going to write this out as beta 1 times month 1 plus beta 2 times month 2, and so on, all the way up to beta 12 times month 12. This is one way of writing it. We could also include we could write this as beta 0. So we could include an intercept term, which would give us the average spending for the base month. But what I'm going to do here is just include one beta for each of the months. So each one of these betas captures the average sales per month. So how would you interpret the coefficient on the December dummy variable in this model? So this is just interpreting, so this is, our December month. So how would we interpret this? Well, this is just the average spending in December. And there's another way of writing this out where, we would write, let me just write this as alternate. So this is spending is equal to, a beta 0 plus, we'd have beta, let's start at beta 1 and say this is not month 1, but month 2. So we're leaving out one of the months. And then we'd go all the way up to beta 11 for month 12. So in this case, this beta 0 is capturing the baseline intercept for all of the months that are not included in any one of these indicator variables. So either one of these ends up being a great answer for A. All right, so lastly, for C, if you wanted to test whether the seasonal spending pattern differs between recession and non-recession periods, how would you modify your model from part A? Okay, so again, this is a pretty difficult question. And a question of this complexity is not likely to show up on the mini-exam. I'm including this here to talk through some of the intuition for setting up this kind of seasonal interaction kind of question. So here we want different seasonal dummies interacted with whether the season is in a recession. So we want a 1 when the month is both in a recession period and is in that month. So we write this as spending is equal to, and I'm going to use this first specification. I sort of like this one better, but if you like this better, that's fine too. So this is spending is equal to beta 1, month 1, and then we don't just want the indicator variable for the month, but we want an interaction term for whether the month is in a recession. So let's call this beta 2, month 1, but then we want to interact it with recession. So we have an intercept term for the month itself, but then we have a second beta which captures whether there's a difference if we're in a recession. And then we're just going to write ... because I'm lazy and I don't want to write the whole thing out. So this would be a complete answer here. There's a lot of coefficients. Python handles this very nicely, but it's hard to write out in a mini exam format. Or because it's not hard to write it out, it just is sort of tedious. Okay, so the interpretation here, and I'm just going to talk this through. The beta 1 captures the average sales in non-recession months. And then beta 2, so this is average sales in non-recession months. And then beta 2 captures the difference in recession months. So different from the non-recession months, how much difference is there in spending? So I would expect beta 2 to be negative. Just because, in recession months, we would expect people to buy less. So this is difference in recession months. Okay. And then I talked about a different question 5, but I mean, one thing we could do here is instead of thinking about interaction effects, we could just write down controlling for children, income, and whether there are lots of purchases online. The interaction, I think, adds a lot of complexity to this question. But I like walking through these more complex questions. But if this is a little bit difficult for you, I wouldn't expect something with multiple interactions in this way on a mini-exam. Although interactions are definitely fair game. Okay, so I think we'll leave it here. I'll see you in the next one.